in and coming back to the day 2 of today's of our workshop. Thank you very much, Mr. Nikhil, and a wonderful platform like PEA. I feel honored to join in. So let us quickly start and resume with the day 2. Resume from the uh, space where we actually stopped yesterday. So today's learning objectives will be starting with the downhole safety valves, where we left yesterday, continuing the completion tools. Then we'll be wrapping up, summarizing the completion assembly. Then we'll moving ahead for against the another section where we'll start with the wellheads. Then we'll discuss about the tubing head assembly, the components of it. Then we'll go towards casing head assembly. Then we'll move towards Xmas tree, and we'll touch upon the gate valves and what are the chokes as well. So moving on, let's start with the downhole safety valves. What is a downhole safety valve? It's one of the most important part of the completion assembly, which is one of the why I am calling it one of the most, because it is the one of the most important barriers in case an emergency situation is occurred. So this is a downhole safety valve, which primary purpose of it is to shut in the well in the event of loss of surface wellhead integrity. It is categorized into 3 types: surface controlled subsurface safety valves. The next one is subsurface controlled subsurface safety valves, which are also called storm chokes, and also the surface valves. So talking about the valve actuation control point, which on which it is categorized into different types. The first one is surface controlled, where it supplies hydraulic pressure to the valve. It holds open the valve against a spring or nitrogen charge that seeks to close the valve. It has a spring inside, which is actually trying to close the valve, and the hydraulic pressure applied from the surface actually tends to keep it open until it fails and the spring acts and the valve gets closed. Talking about the subsurface controlled, it is actually operated by the flow from the well itself, and it has to be used in some cases where we don't have certain facility to apply hydraulic pressure, and we don't have a nipple inside to install the downhole safety valve. In those cases, we install the subsurface controlled subsurface safety valve or a storm choke. So subsurface controlled downhole safety valve looks something like this, where it is also referred as storm chokes, as I mentioned earlier, and it is activated by a maximum flow of the well. It is operated, its parameters are designed in a way, and its operating parameters are set in for the valve so that the maximum flow of the well is keeping it open. So in that case, where the flow gets down by any reason, by any factor, the flow gets reduced. So in this storm choke will actually identify it as an emergency, or the value of why it has to be closed. In that case, it will close the storm choke, and the well gets shut in. But the one major thing is it requires a monthly calibration to be ensuring the effectiveness of the valve. Talking about surface controlled downhole safety valve, it has a hydraulic supply from the surface. It has 2 types, majorly 2 types. It has a ball type and it's a flapper type. So it is categorized inside the flapper or a ball, which actually is the main part of closing the valve. and mode can be set tubing retrievable, and the other one is wireline retrievable. So flapper type, talking about the flapper type surface safety valve. So this is the flapper inside. You can see here. This is a flapper type downhole safety valve, and this is the flapper, which is actually having a spring below that, and it is tending to close if this tube is not applying pressure on it. So this tube actually keeps it open, moves inside the safety valve and keep the flapper open and make the connection from here to here and make it seemingly with a seamless bore inside the safety valve. And once the hydraulic pressure is released, this tube goes back and the flapper closes. The other one has a ball inside, and this piston is moving inside just like the flapper type, but the main difference is this is a kind of a ball valve where this ball moves round and this closes the valve and opens the valve when the hydraulic pressure is applied on it. So I want to show a very small video to you where it is showing the operation of opening and closing the valve. So let me describe this video to you. So here, this is the tube which moves inside. This is the spring of the safety valve. Here is the hydraulic pump, hydraulic hand pump, which is connected through the hose. The hydraulic pressure is going through the hose inside the inlet port of the hydraulic pressure, and that hydraulic pressure and hydraulic oil is going inside the chamber, which is trying to move this tube inside, the concentric tube inside, against this spring. And here is the flapper. So this tube has already touched this flapper and it's moving against the spring of the flapper, and flapper is open right now. The applied pressure is tending to move the tube below, making sure that this tube actually keeps the flapper open and makes a connection to the below part of the safety valve. So we can see it keeps moving. So now this tube has made a connection with this one, and this has ensured the full bore open inside the safety valve with whatever is the ID of this safety valve is. Making sure the flapper is completely open and the pressure is applied, pressure is locked from here, the hand pump, and the pressure is already applied. Now, the person in the video will be releasing the pressure from the hydraulic pump, and you can see that this tube will go back and this flapper will close it again, making the downhole safety valve close as required. So I hope this was clear enough. This flapper is closed again. This tube has gone back to its original position, and this flapper is closed again, making sure that the downhole safety valve is closed, and this flapper holds pressure from below as per the pressure rating of the downhole safety valve. Moving on. So let's discuss about the types of downhole safety valve in another category. So how we can retrieve and set the safety valve. So one type is tubing retrievable, where it is run and set with the tubing and joined with the tubing. It has pin connection and box connection above and below, and it has threaded connection which actually joins the tubing itself within the completion assembly. And the other one is wireline retrievable. So the wireline retrievable is set inside a nipple, a dedicated specified nipple inside the completion assembly, where this wireline retrievable is set through slick line, or you can say wire line, and set in the nipple, so that this gets the hydraulic connection gets set inside between these two seals, and the hydraulic pressure is applied on that, so making sure the piston gets open. So talking about the deploying and retrieving, the wireline retrievable safety valve is deployed on a wireline running tool to be installed in an appropriate landing nipple. And it is easy to install and retrieve by wireline. And then but it's a significant restriction flow path. So whenever we want to make an intervention run, whenever we want to do an intervention job, we have to retrieve the wireline retrievable safety valve before going in with any kind of tool string, regardless of slick line, wire line, or coil tubing. In that case, we have to set a dummy safety valve inside that nipple, so that the hydraulic pressure is the hydraulic oil is not lost from the autocon panel or the control panel. Talking about the tubing retrievable safety valve, it is an integral part of the tubing. As I mentioned, it has threaded connection, which is connected to the tubing above and below. There is no restriction in flow path ID, because it is making sure the flow path ID inside the safety valve is exactly the same with where the tubing is. And it has to be, the disadvantage has to be pulled out the whole completion to retrieve and repair it. If it has any problems in the flapper, if the flapper gets stuck open or stuck closed, if there is an issue in the control line port, if there is a leak in control line, the whole completion needs to be pulled out for repairing the issue. So let's summarize what we have learned until now, the whole session yesterday and some part of today. So summarizing, and I wanted to make sure that you guys try to understand and remember the sequence, the correct sequence and the correct placement of the completion assembly and different tools inside. So let's summarize this. We started with the wireline reentry guide here. Let's keep a track on this typical conventional completion assembly. So we started with wireline right at the bottom. Then there has to be a pub joint we have to install. Then there will be a bottom no-go nipple. Then there will be a perforated pub joint. You can see here. And then there should be a top no-go nipple for plugs setting, the bottom no-go for pressure gauges setting. Then there has to be a pub joint above the top no-go in case the plug gets stuck and we need to retrieve the production. So we have an accommodation to perforate that and get the production back. Then there is a mill out extension in case we need to mill out the packer and get the complete tail assembly out with rig. Then there is a seal bore extension where we are having extended seal bore area below the packer to ensure that the locator seal assembly seals have enough polished bore to move up and down as per the temperature conditions of the well. Then one of the most important production packer, which has a lot of functions we have discussed. Then it completes the tail assembly right from the wireline reentry guide to production packer. Then the upper completion assembly starts from locator seal assembly we have discussed yesterday. Then above it, as required number of tubing joints as required. And then there you can install a sliding sleeve door as per requirement We have discussed what its function is, what its applications is, what it can do for us. Then again, there has to be some tubing joints above a sliding slide door as well. Then we have learned about flow coupling, what its purpose is, what its function is. Then the triple SV, the downhole safety valve, we have just learned, which causes a restriction. And there is another flow coupling above safety valve. So there will be one flow coupling each above and below the safety valve, which is making sure that there is a controlled amount of erosion, and there is no well integrity issue later on. And then again, until to the surface, there has to be a tubing joints required, and then there will be a tubing hanger right at the top. So tubing hanger we'll be discussing in the next phase. So moving on, this is a typical single completion where in one go, where we can see here, violent ready guide, no nipple, and you can see the whole completion assembly in one go. All right, so moving on, let's start with wellhead. Wellhead and Christmas tree. So what is a wellhead? Let's try to learn something about it. So wellhead is an assembly of heads or housings, casing hangers, pack-offs, casing spools, tubing hangers, tubing head adapters, valves, and other fittings, and control devices utilized to control the well during both the phases, where the wireline, completion phases, and drilling. So wellhead is a set of the tools and assemblies and the hangers. So in combination, we call them wellhead. So the surface termination of a wellbore, it incorporates facilities for installing casing hangers and during the well construction phase. And it also incorporates a means of hanging the production tubing and installing the Christmas tree and surface flow controlled facilities in preparation for the production phase of the well. So this in complete, we will discuss each and every part in detail in coming slides. Moving on, the common features of a wellhead, it supports and suspends the casing string. It provides a connection point for the product pressure control equipment. It contains well pressure as well. It allows access into the production and annulus bores. And there are three types of wellheads. As far as the connection is concerned, it is independent, which is a screwed connection. There is a non-conventional for specific and special conditions. And then there is a conventional, which is a normal flanged connection wellhead. So starting to learn in detail what is a wellhead and what are the components of a wellhead. So starting with the tubing head assembly. So this is a combination of different components of the wellhead, where this highlighted part is the tubing head assembly. So this is a tubing head assembly. This is the inside bore, and this is a flanged connection tubing head assembly. This is a dog nut or a tightening screw. So this is actually a tubing head assembly which provides a means to suspend and seal the production tubing in the wellhead. The tubing hanger sits inside the tubing head assembly. I'll show you. So tubing head assembly functions. It suspends the tubing with hanger. It provides a hydraulic seal between the tubing and annulus. It provides access ports to annulus. And it provides mounting to Xmas tree. So here we can see tubing head assembly, where this particular part is tubing hanger. It has seals here. This is the dog nut tightening, making sure that the tubing hanger remains at its place. And here is the tubing, which is connecting all the components of the completion assembly. This is the last joint which is coming to the surface, and this is connected through the threads connection with the tubing hanger. So this is basically the tubing hanger hanging the whole completion, upper completion assembly from here. Moving on, we'll try to learn about different components. So this is the bowl of the tubing head assembly. This is a lockdown screw. Lockdown screws are used to lock down the tubing hanger at its place. This is the load shoulder, which is used for the tubing hanger to sit in. This is a secondary seal area, which is used by the body seals of the tubing hanger. This is the test port to make sure that the upper seals and lower seals are actually holding and there is no leaks in the assembly. Then this, you can see here, is a ring gasket groove where there has to be a ring gasket in between a connection of two flange connections. So this flange gets connected to a bottom flange for of another component, and in between there has to be a ring gasket to make sure that this has no leaks and for a normal sealing. So this is the lower flange. This is the outlet of the annulus of the tubing head assembly, and this is the upper ring gasket groove as well, where the another component, actually the Christmas tree itself, will be connected from here, and there has to be a ring gasket connected inside. So talking about the tubing head spool. So this is, you can see, a tubing hanger set inside the tubing head adapter, and this is a lockdown screw locking it in, making sure that it holds its position at its where it is set. A wellhead component that supports the tubing hanger and provides a means of attaching the Christmas tree to the wellhead. And it is an equipment attached to the casing head spool used to hang the tubing and seal the annulus between the tubing and casing. So it's actually providing a seal, the primary seal at the surface between the annulus and the tubing, and it is making sure that it holds the whole completion upper assembly, the whole weight and everything which is connected to the tubing hanger. So let's see together the tubing hanger. This is the neck seals. These are the body seals. This is the lower end of the tubing hanger where it has threaded connection, and it has threaded connection for the tubing to be connected through it. So the tubing is connected from the bottom, and there is these are the threads I'll be discussing a bit later. These are the threads to set the back pressure valve or a BPV. I'll discuss in the later slides. And you can see this tubing hanger gets set inside the tubing head spool. The lockdown screws locks the tubing hanger at its place. The tubing is connected, the landing joint is connected, is directly to the tubing hanger itself. And then this one is actually, this needle valve is showing the control line connection, which goes down to the downhole safety valve for the downhole safety valve hydraulic connection. So this is the control line which is having a surface connection, and while it is making a surface controlled downhole safety valve. So this is the connection going through it. So the tubing hanger could have this port and could not have this port. So while ordering the equipment, we have to make sure that the correct equipment comes in, and it has a proper port if it is required at the well site. Moving on. So what is a tubing hanger? Tubing hanger actually is a tool which suspends the tubing and provides a primary annulus seal between the tubing and the production casing. As we discussed, its position, it is actually providing the seal between the annulus and the tubing, and it primarily holds the weight of the tubing and the whole completion upper assembly, and holds the complete completion assembly load as well. So tubing hangers are installed in the bowl of the tubing head, as we have seen in the last slide. It is set inside the bowl. It has a special bowl to set the tubing hanger inside the tubing head assembly. Tubing hanger are run through the blowout preventers while the BOPs of the rig actually, and are landed in the top bowl of the tubing head spool. And it also acts as a means to access and manipulate additional smaller tubing lines that are utilized downhole. For example, the control line, as I discussed. So this is the opening, and this is the opening having through this for the control line opening, and it is extended to the surface on the outside of the tubing strings or strings. So let's see what are the components of the tubing hanger. The OD seals are on the neck. These are the neck seals. This is the neck part. This is the profile for the back pressure valve. We'll be discussing in later slides. Then it has a seal compression ring, which is making sure that the seals hold properly. This is the hanger body. This is the hanger neck. This is the neck part of the tubing hanger. This is the body part of the tubing hanger. Here are two control line or instrument line connections. You can have one, you can have two as per your requirement, and the vendor will be manufacturing it as per your requirement. This is the landing shoulder. The landing shoulder tends on the groove made for setting the tubing hanger inside the bowl of the tubing head, and this is the part actually which is sitting inside the bowl of the tubing head, and this is the tubing threads, which where the landing joint, the tubing joint of the upper completion assembly directly connects to. And this is the seal element. These are the body seals. So these are the body seals, and these are the neck seals here. So what is a back pressure valve? I have been mentioning earlier. Back pressure valve is actually installed in the tubing hanger to hold pressure. It is kind of an NRV, non-return valve, where it has a specific purpose. So it is installed to hold pressure from below during the following operations. So it is installed inside the tubing hanger while before nipple down or nipple up the drilling BOP stack. It is installed before nippling down and up the Christmas tree. It is installed for testing the Christmas tree, and in that case, we actually install a two-way check valve instead of back pressure valve. And if we want to replace the master valve of a Christmas tree, or we want to repair the master valve or any gate valve of the Christmas tree, we have to install the back pressure valve inside the tubing hanger, making sure that it is one of the two minimum required, two mechanical barriers minimum required by the IWCF. So this is considered one of the mechanical barriers for well integrity. So here we can see this is a back pressure valve where this has a spring, this rod has a spring, this piston is making sure that it is holding the pressure from below. While a BPV is installed, we can still pump anything, any pressure, any fluid for pressure equalization or any purpose from up, and the spring goes down, this piston goes down against the spring, and we can apply pressure, but it holds everything from below to coming up. And the two-way check valve is holding the pressure from both sides. If we have installed a two-way check valve, so as the name suggests, two-way check valve, it will hold the pressure from below and above at the same time. This is the seal of the body. These are the threads against which it is set. It is screwed in the tubing hanger. And this is the handling thread. Handling threads are actually used to actually set the BPV or TWCV, where these are the threads where the running setting tool and retrieving tool is connected to the threads. And it has a special tool In both cases, if it is a pressurized well, we use a lubricator, and if it does not have any pressure, so there is an iron rod or a T rod which is used to install a BPV or a TWCV inside the tubing hanger. So the the BPV, this is a TWCV, this is a BPV. It is installed here, as you can see. This is a tubing hanger. This is a BPV installed there. And this complete assembly is the tubing head assembly. So this is actually maintaining the sealing. This is the BPV, and this is the tubing hanger, as you can see. I hope it is clear for you guys. So talking about casing head housing. So casing head housing is actually screwed or welded. We have both the options on top of the conductor casing, and it serves to anchor the BOP to the first casing stack during drilling. It supports the above ground well completion as well. It supports the next smaller casing stack via the casing head spool and the casing hangers. And it also seals the annular space between the two largest casing stacks, ensuring the access to the annulus. So this is the casing head housing, where it has to support support the above ground well completion as well, and it is used with in the drilling phase while installing. So talking about casing head housing, I have highlighted here, this is the part in the whole assembly, wellhead assembly. This is the part which is actually a casing head housing. It is connected to the base plate, which is actually sitting on the ground level. Usually on the offshore, it is visible on the platform, and in onshore cases, it is inside the cellar. These are two types. The connection types are slip-on or welded connection, and it can also be connected through the thread. So learning about casing head components, this one is a casing head housing, where this is a hanger bowl. This is the ring gasket groove. Again, the ring gasket is one of the most important seals between the two flanges. If we want to connect to any two flanges, it has to be a specific and a specified designed ring gasket, which is as per the size of that flange. This is the load shoulder for the casing hanger to be set, just like the tubing head assembly and tubing hanger. It also has a shoulder for the casing hanger to sit inside and bear all the load of the casing string. This has the outlet for the maintaining and measuring and monitoring the annulus pressure. It should be zero always. If it has any pressure on the gauge, we have to always keep it monitoring through the pressure gauge, and if it has any pressure, then we have to act upon it. Then this is the bottom prep. This is a test port to make sure that the seals are holding properly. This is the upper flange part, and this is basically the casing head assembly. So talking about the casing head spool, if a well includes one or more intermediate casing strings between the surface, we can have a deep well where we can have more than one intermediate strings. So between the surface and the production casing, the next component required after the casing head is the casing head spool. So this is required in those cases where we have more than one intermediate casings. This is the whole completion, whole wellhead assembly, and this is the part where I have highlighted the casing head spool. Its functions, it provides for attachment to the surface casing string. It supports BOP while the hole is drilled for the next casing string. It provides outlets for annular access. It provides for testing BOPs while drilling. And this is a casing head spool you can see here. This is installed above the casing head assembly and below the tubing head assembly. Here you can see a tubing head adapter, your tubing head assembly. This is again the tubing hanger. The tubing is connected through the tubing hanger. This is a casing head spool, and that it was a casing head assembly. And this is the base plate. These are the casings. The casings are connected to the casing hanger inside the casing head assembly. So this one is conductor, this is surface, and so on. So what is a casing hanger? Casing hanger is actually attached to the end of a given casing string and suspends and seals the casing string in the top bowl of a casing head spool. So casing hanger, just like the tubing hanger, it has almost the same function, but the main difference is that it holds the casing and the tubing hanger holds the tubing, as the name suggests. The casing hanger sits inside the casing head spool. It has a load shoulder on which the casing head sits on and sets on. Then again, it has the dog nuts to make sure that it holds properly. And these are the seals which are making sure the seals are intact and the annulus pressure is hold there. And casing is connected and hanged through the casing hanger here. So its functions are to suspend the casing load. It allows weight or tension load of a casing string to be transferred to a casing head or spool. It bears all the load of the casing string, and the casing load is suspended on the casing hanger directly. It packs off and seals the OD of the pipe and the ID of the head. So it creates a seal between these two things. And it also makes sure that the casing is centered and it is make sure that it creates an annular space as well for the later use. And it also allows for testing of connections, where we can have, as per requirement, we can test different connections through the ports given for at any point of time. So learning about the Christmas tree. What is a Christmas tree? Christmas tree is an assembly of the valves, spools, pressure gauges, and chokes fitted to the wellhead of a completed well to control production. Christmas tree will always be installed if you have hit the discovery, if you have a discovery, if you want to produce a well, and it has to be there once you have gathered the information that you have hit the reservoir perfectly. Christmas trees are available in a wide range of sizes and configurations, such as a low or high pressure capacity or a single or multiple completion capacity. So here we can see is actually a dual Christmas tree, and it has a wing valve and a production valve. I'll be discussing all the valves in later slides. So an assembly of valves, spools, and pressure gauges fitted to the wellhead, and then it is having a different set of valves where these are set in a way that each and every component of the Christmas tree is having its own function and purpose, and the placement of it is also having one of the major factors. So here we can learn that this part is wellhead. When I started the wellhead section, I called this section as a wellhead. So this is a wellhead, and above it is a Christmas tree, where it is starting from bottom. The Christmas tree has a master valve, or if we mostly like 99% of the times we have another valve, a gate valve just like this, or an actuator valve. So gate valve and actuator valves I'll be discussing in later slides as well, but this is a gate valve. These are all the gate valves, and another gate valve above before this cross makes it the upper master valve, and this one becomes a lower master valve. So for any point of time throughout the life or cycle of the well, this lower master valve will not be closed. Remember, the lower master valve will keep open throughout, and nobody touches the lower master valve. I'm telling you something which is field operations practice. Whatever you want to do, you have to, if you want to shut in the well, you shut in the well through the wing valve, and then the upper master valve closes down. And then if you want to rig up or rig down the well interventions, you have two barriers. You have close the downhole safety valve as well, and you close the lower master valve only in that case when there is a person supervising the operation. Otherwise, the lower master valves are always open. This is a wing valve, and this is a choke. So I'll be discussing chokes in detail in later slides. This is a wing valve, and this is a kill wing valve. So this is a production wing valve, this is a kill wing valve, and it also has a choke installed there. And this is called a swab valve, where this is the first valve we will close when we want to start a well intervention operation. And this is something which will keep it open for the gauge on the tree cap or the top connection to read the flowing wellhead pressure or a shut-in wellhead pressure. Most of the time, the swab valve is kept closed because the flowing wellhead pressure is measured on the wing flow production wing side, and this is a complete assembly of the Christmas tree. So the combination of different gate valves makes a Christmas tree. So let's learn about something about the gate valves. What is a gate valve? So gate valve, as the name suggests, it has a gate inside the valve. It is an on and off valve. So on and off valve means you can only keep it open or keep it closed, and it cannot be used for choking down or choking up the valve to flow a stream. Either you can open the gate valve or close the gate valve, and it is prohibited, and is strictly prohibited that you you don't completely open or close the gate valve, because this is made in a way for a specific purpose, so that the gate gets eroded if it is not closed or opened completely. So it is ensured that the gate valve is always opened completely or closed completely. The gate valve has high pressure resistance. It can come in different pressure ratings. It has a high durability. That's why it is one of the most widely used and the basic component of the Christmas tree. It provides a full bore access. The gate itself provides a full bore access when it is opened completely, and it is easily repairable. The components are easily disassembled and assembled back if there is any kind of choking or any kind of a restriction inside. So this is actually a gate. By the name it's coming. This is a gate. It is connected to the piston shaft of the handle, and this is the flow path. So in this way, right now it is completely open. The gate opening is directly aligned with the open bore of the valve, and if we want to close it, so this gate starts moving up, and the gate opening starts to disalign from the main bore, tending it to close the valve. So if the gate opening is not aligned with the opening of the main opening of the gate valve, it actually means that the gate valve is closed in that way. Another kind of valves are actuator valves, which can either be operated by pneumatic supply, which is an air supply, or a hydraulic supply. So these are the actuator valves, where these are usually installed as an upper master valve, and it is also installed as a secondary production wing valve after a production gate valve on the wing side, for better safety and better integrity of the Christmas tree. This is the rod. This is the indicator shaft, which goes in and out. This is the gate inside. Again, just like a gate valve, it is actually and primarily a gate valve, but the actuator, the operating point is different. So it has an hydraulic connection. This is a side glass where you can see the rod inside, and there is an opening. When you see it open, so it means this is open. And another indicator is this rod goes inside right almost at the end, which actually means from surface and by naked eye that the valve is open right now. And and it is operated by hydraulic oil, hydraulic pressure, where this is the piston which goes inside, and this stem actually is connected directly to the gate. So right now it is closed, the rod is outside, the gate is not aligned through the bore of the valve, and this is a closed position for this valve. And this one is again an actuator valve, but it has a pneumatic supply. Let's discuss something about the chokes. So what is a choke? Choke is actually a device used for several reasons, but primarily to control the flow rate. So these have two types, positive or a fixed choke, and the other type is adjustable choke. So right now you are seeing an adjustable choke here, which is actually a valve in a way, but it is used to optimize and it is used to maneuver the flow, which we cannot do with a gate valve. So this does not have a gate inside. This is a choke. And this is usually used for maneuvering and manipulating the flow according to the requirement, and which we cannot achieve with a gate valve. So what is the purpose? Applications is to reduce the pressure and improve safety. Sometimes we need to control the pressure of the valve. If we are having any issue in the flow line or any facility and or in a separator, so we need to control the flow. So this is something which we will use to control the pressure of the well, the flowing pressure, flowing wellhead pressure FWHP, and improve the safety at that particular point of time. It is also used to set a certain flowing rate according to the test sequence. If we are doing a well testing operation, so we have to use this adjustable, this choke. I mean, I'll be going ahead with the different types, but the choke is used primarily for maintaining flowing rate as per requirement, or to the selected production flowing rate as per required by the well testing operation. It also prevents sand entry from the formation. If there is a sandstone and it has a very unconsolidated sand and it's you are having major issues of sand production, so we can use the choke on the wing valve to reduce the flow rate, eventually resulting in a less amount of sand entry inside the flow lines, making sure that we have less amount of issues. And then it is also used to produce the well and the reservoir at most efficient rate in the production wells. And the final one, we use it for prevention of the water and gas coning in a way that we can control the flow and at an optimum flow rate that the water and gas coning is not achieved at that point of time. Moving on, types of choke. So there are primarily two types of chokes: fixed choke or a positive choke, and adjustable choke. So what is the main difference between these two chokes? A fixed choke has a fixed beam inside the choke, and it does not have any handle. If you can see, there's a main identification by the naked eye. This is not having a handle because this does not have a facility to adjust the choke size. It will have one choke size at one point of time, and if we want to change the choke size for the flow, so we need to stop the flow through the fixed choke, and we have to change the beam size inside. This is the bean inside, which goes inside, and it has a specific size. It is written on the choke bean, and this is a fixed choke. Whereas the adjustable choke has a handle to maneuver. It's almost similar to a gate valve where the handle is connected through a piston, and the main part controlling the flow is this cone. This cone is specifically and specially designed and maintained to control the flow at different choke sizes. So this particular part has markings of different choke sizes, and this stem goes in and out as per the requirement, so that we make sure that the required choke size is achieved through this handle. So this handle is actually used to have an adjusted amount of choke flow stream wherever required. And usually during the well test operations, what we do is we always and majorly take the flow from the fixed choke. And whenever we want to change the choke size after any given point of time, like after 12 hours or 8 hours interval, we need to change the choke size. So in the choke manifold, we divert the flow through adjustable choke of the same size, and until we change the choke size in the fixed choke. We don't want to stop the flow, so that we maintain the well testing operation and keep it carry on. And this choke size or in the fixed choke is changed to the required, the next one, as per the program. And once it is set, then we divert the flow back to the fixed choke and close the adjustable choke. So this is the main criteria and the main line of action while maintaining the choke manifold for a well testing operation. So what is a fixed choke? It is used in applications where the well flows at a constant rate. It has a fixed beam or orifice, as I told. This is a beam. It is having a choke inside the beam. It's a very small opening in the beam, and this is a fixed choke. And it has to be disassembled to change the beam. As I said earlier, that the outer part, the connection part, has to be disassembled to change the beam size. We have all the beam sizes available on the surface, and whatever is required, the beam size is changed to the next choke size. Whereas the adjustable chokes are used in applications where it needs an optimization of the flow stream. As I said, if we want to maneuver at different choke sizes, maneuver the flow as per requirement, then this is the thing we need to use. This is the adjustable choke. So this is used primarily in the choke manifold in the well testing operations, and also this is the adjustable choke which is connected right after the wing valve, right after the production wing valve, or some place later in the flow line to adjust the flow as per requirement. As I showed you in the earlier slide in the Christmas tree, this is the adjustable choke. Now we know that this is an adjustable choke. We can add another valve on the production wing. So this is a production wing valve, and then we can add an actuator valve for added safety and added control of the well and added barrier. And then there will be a adjustable choke to control the flow as per requirement, because these valves, the gate valve and the actuator valves, cannot be used to control the production or lessen the production flow, and it can only close down the well or either open down completely. So this is something very important while producing a well. So moving back to the types. So this is an adjustable choke. As we have discussed, this is the piston going inside, connected by the handle, and this is the flow stream. So this part, this cone, will control the choke and control the flow through this stream. And this is the flow path. All right, thank you very much.